Hey guys, and welcome back. Today we're going to be talking about domain and range for quadratics, reasonable domains and range, values of the domain and give the range, so all of that good stuff. Today we will describe a reasonable domain and range for a quadratic function. So example 1, we have this graph. So I'm just going to go for it. I want to solve for the domain. So I am looking at my x values, lowest to highest. So I'm going to scan this way. I see that my domain has an open circle and then an arrow on the other side. So I have 0 is less than x, because I could put 0 is less than x, which is less than or equal to infinity, but for this case, I know that if I just put 0 is less than x, I know that that means it's continuing on forever. All of my x values are bigger than 0, but they're not 0. They're just bigger than 0. So next we have our range. I'm actually going to start at the top because I have a curve, and I'm going to scan downwards. So my range, I can see that I don't have a lowest point, but I have a highest point, and it is touching. So y is equal to, or y is less than or equal to positive 3. This, if I want to, so you're going to have two ways to write these, inequality and verbally. So inequality for this one, for the domain, was 0 is less than x. Verbally is all real numbers greater than 0. Okay, we read from the variable. And for this one, all real numbers less than or equal to 3. Make sure you know that wording because you're going to see it on your test. Example 2. Given the quadratic function f of x equals x plus 3 to the power of 2, if negative 7 is an element of the domain, what is the corresponding value in the range? So these are actually pretty simple, even though they sound really wordy. So steps, plug in for x, and then solve. So we're just putting that negative 7 in for x, okay? So I'm going to put it right there, negative 7 plus 3, and then to the power of 2. So negative 4 squared would just be 16. And that's it. Yeah, because domain is your x value, so you're just plugging in for x. Example 3. A pumpkin is catapulted into the sky utilizing the function as its path projection. So f of x equals negative 1x squared plus 7x plus 5. What is a reasonable range for the situation? So when we see reasonable, that means what makes sense? If I am catapulting something into the air, is it going to go below the ground? Is it going to go back in time? No. So for these, what you really need to understand is your y value is your height. So your y value is your height. Your x value is your time. So the amount of time that's spent in the air. So graph the function and draw reasonably. So you can graph this on a graphing calculator first. So I went ahead and graphed mine on Desmos. Notice that it goes into the negatives, it goes down below the ground. If the x-axis was the ground, this is way below. So what is a reasonable? I would just redraw it on my own little sketch like that. So I just want everything to be in the positives because I'm not going back in time. I'm not going below the ground. Once it hits the ground, it's done. Like that pumpkin is smashed and it's just not going to go anywhere else. It's not, it may bounce, but for this scenario right now, we're just going to assume that it just stops. Okay. So I'm looking for my range. If we were looking for our domain, we would go left to right, but I'm looking for my range. So I start at the top, scan down for this. And I see that my range is 0 is less than or equal to y, which is less than or equal to 17. And I know I didn't say find the domain, but if I were to find the domain, it would just be 0 is less than or equal to x, which is less than or equal to about 7.5-ish. Sounds right. Okay, that is